Thanks. Okay, so my name is Nick Burch. I'm Director of Engineering at a small startup called Veck. I'm also involved in a few of the Apache content projects, and I'm involved in things like community development and incubator and so on. So, before I begin, you'll be able to find, or you can find, all of the code and all of the test data up at that URL, as well as the slides. So if you want to take a photo, this is your chance. What I've got is too much content for the time we have available, because I'm not sure quite what level everyone's at. So I'm going to do a show of hands in a second to gauge that, so I know which slides to skip over. And if you're unfortunately one of the sort of 2 people that put their hand up for a section I skip over, then you can get the full slide deck, and you can then see the bits that I went through quite quickly. So who here has done some stuff with an AIML framework like Apache MXNet or Scikitlearn? Any hands? Got a few? Okay. Who's done stuff with natural language processing? Got a few here as well. Okay. I'll do my best to cover off those things. So, the other thing is, I've got the code available on a Microsoft Azure notebook, so if you want to, you can go here and get the Apache MXNet code for this. And then as well, I gave a version of this talk at Berlin Buzzwords here, so you can watch the video of that later. This one is also being videoed, so you better catch up on that. And then finally, here's the simpler Scikit-learn version if you want to have a play with that code and work along with that as well. Nice thing about Azure Notebooks is they're free. Microsoft have pre-installed most of the things you need, though sadly not Apache MXNet, so you have to install that. But it means that you can have a play with a lot of this stuff without needing to install anything on your laptop. So if you're on a corporate laptop, you don't have to worry. You can try it on the cloud. If you're on a Mac and installing Python stuff is a pain, again, you don't have to worry. It's all up there for you. So, this is not your typical AI talk. We're going to be focused a lot more around textual content. Going to look at how we can do some very simple AI stuff for text, and then we'll take it through to a more complex bit. And then I'm also going to tell you at the end about some of the things to be aware of and some of the other Apache projects you might want to go and investigate. Okay, so what's AI and ML, and why is it one of the hot topics here today? So AI, artificial intelligence, ML, machine learning. Larry Tesla's theorem is AI is whatever hasn't been done yet. So maybe ML is everything that we can go off and do today. First big AI bubble, maybe a few people in the audience were around for that. In the mid-1980s, over $1 billion was spent on AI startups, which were often at the time called expert systems. They had 2 big drawbacks that caused the bubble to pop. One of them is that they didn't have enough training data to build their systems. And the other one is that the computers were a hell of a lot more expensive than the experts that the expert systems were trying to replace. So no training data, more expensive than the old thing, pop. Okay, what about today? So Moore's Law, hopefully everyone knows Moore's Law. So $1 million worth of computing power in 1985 from the heart of that original boom, that's under $1 today. If you go on Amazon with your credit card, you can rent a machine with 1 terabyte of memory for about the cost of a latte per hour. Okay, 4 terabyte machine, $25 an hour. There are an awful lot of problems out there that can be solved for about $12 by renting a machine from Amazon, loading it all up into memory, processing it, dumping it out. And then also we've got a lot more data to train our models on, and we've got a lot of these awesome open source libraries that make it really easy. You don't have to sit there with all your maths textbooks and everything figuring out how to do the AI and writing the code for it in Fortran or something like that. You can just go pip install MXNet, wait while it sucks down a third of the internet, and then off you go. Okay, who's seen this XKCD? There is a little, well, actually quite a lot of truth in this, that people can just play with the AI, tweak the parameters, and maybe they'll get the right answer for their one testing, and then they'll call it done. Hopefully, a lot of you in the audience are aware of this issue, and will be trying to make sure that your systems have a reproducible pipeline, that you actually store your hyperparameters, that sort of thing. But do please, before you try and make any important judgments based on your AI, be aware of what's gone into it and how to reproduce it. Okay, so typical AI demo is image classification. So it's fun, it's easy, makes for a great demo. Okay, who can be an AI? What's this? Dogs or cats? Okay. This one? Dogs or cats? Yeah. So if you've just trained a binary classifier to say dogs or cats, and you feed it a koala, not going to work. So first AI lesson, it's only going to be as good as the training data and the problem you taught it on. Binary classifier, A or B, you feed it C, it all goes wrong. So, okay, train an image classifier. What animal is this one? Kangaroo, okay. What about this one? Wombat. And this one? This one's an echidna. So again, we've built this great training system with images, and we've just discovered that our experts in the room don't know what it is, so they can't classify it, so we can't get the training data, and it all falls apart. Now, my data, though, doesn't look like that. My data looks like this. A lot of you probably have this kind of data. So it's no good trying to get a bunch of humans on the internet to give you answers for this sort of thing, because you might not be able to share these kind of things with random mechanical Turks on the internet, and even if you do, they might not know what the answer is. You probably have people in your organization that do, but they tend to be really busy. So what I want to talk to a little bit today is about what to do if we don't have the great training data, we don't have the ground truth. Okay, if you were interested in an image classification talk, this was a brilliant one given in this very room about 18 months ago, so you can go look that one up, and they've also got the video of that online. But we're not going to be doing image classification, we're going to be doing text. So I've got lots of policies, I've got procedures, I've got training guides, I've got help information. And it's all in Word documents, it's in spreadsheets, it's in slideshows, it's on wikis, all that kind of thing. And I need to do inexact searches over them. So I've got some project training material, and I've got someone new to the project. Now, you could just say, well, we're going to spin up an Elasticsearch instance and away we go. The problem is that someone new to the project doesn't know the right terminology. So it's no good saying, oh, there's the Elasticsearch, we fed all the data in, because they don't know what to type into the search engine to find the answer that they need. So at the moment, they just keep messaging the really busy team lead and asking them. And it doesn't really scale, it really limits how quickly we can ramp people up. Got RFP questionnaires, lots of customers saying, hey, we might want to work with you, but here's our wonderful list of questions, go and fill them in. And they're always asking us the same things, but they never use the same words, and they always insist on using their own templates. And unfortunately, because we want their cache, we can't say, no, you must use our format. We just have to use theirs. And the workaround is that lots of really busy people keep rewriting the same text because the question's slightly different and the contracts team can't find it, and oh, it's terrible. And then job titles in job postings, people say, oh, you know, I need a developer, I need a senior developer, I need a Java developer, I need a Java engineer, all these kind of things. It's all the same thing, but they're using the wrong terms. And so we can work around this by giving a little translation guide to the people, but then they get grumpy because it doesn't match what the client wanted. And again, it's a pain because we haven't got one ground truth. We haven't got one answer. We've got the complex world of human language. So my other problem is I can't show you most of the documents that I use internally to train on this, but I do have all of the Berlin Buzzwords talks available. I picked Berlin Buzzwords because the ApacheCon website changes who's producing it an exact URL format a lot, whereas the Berlin Buzzwords one is quite stable, fairly similar set of talks. So I'm going to use the titles and the abstracts for a few of the examples, because we might want to find talks about AI and ML and all the different things, and it's a better example than documents I can't show. So they look kind of like this, a title, bit of text, whole load of keywords and things. So what do we want to do? Well, one of the things we might want to do is sort of a bit like clustering. If you're interested in this talk, what other talks might you want to go and find out about? Partly it's a recommendation thing. People who are searching and found this talk, what other searches were they interested in doing? But it's not exact matching. We don't have wonderful classification labels. I haven't been able to get anyone, no matter how much beer I promise them, to go through and label every single talk in this conference with particular specific labels so that we can do exact matching. Unfortunately, I can't really A/B test it. I can't, at the end of the conference on Thursday, say, OK, everyone jump back in the time machine, try a different set of talks, and then tell me if my system was better or worse the second time than the first time. And it also struggles with people that give really wacky, fun titles. So we've got this inexactness, again, affecting us. Another issue is that AI and ML frameworks don't like Word documents. They don't like PDFs. So Apache Tico jumps into the rescue. There was talk in here an hour or so ago about Tico as well. So it lets us hand over this messy Word document, or maybe even thing that we don't know what it is, and get back some nice semantically meaningful HTML or some metadata or some plain text, so that we can then get something that's text that we can feed into the AI and ML. So the first thing is you probably got all these Word documents and whatnot. Make use of Apache Tico, get the text. Right, text, awesome. Here we are. If you were to go to the URL and look in the sample data, you'll see JSON that looks like this with our tracks and titles and so on. OK, text, JSON, clean, no Word documents, no funny accents. We're all set? No. None of the AI and ML frameworks talk JSON either. And they don't talk JSON of text. What they want is ones and zeros, or things between. Anyone remember matrix multiplication, that sort of thing, from maths classes or university and so on? Unfortunately, most of the AI ML stuff ends up with complicated vector space diagrams. You don't need to know all of it, but you do have to translate your stuff into that kind of thing so it can work. Now, you can have sparse matrices where only the odd thing is filled in, or you can have really dense ones where almost every position in the matrix has a value. If you have quite a large number of features in your data, then you're going to need more memory and more CPU. If you can shrink it down to a smaller set, then it's going to be a bit cheaper, but maybe a bit less precise. So here's your next challenge. How big is your laptop? How big is your data center? How much credit limit is there on your corporate credit card that you can get away with burning on Amazon? That's a trade-off that you're going to have to make, and that's going to affect what goes on. OK, we had a few people in the audience that didn't put their hands up for some of the AI and ML stuff. So a few key bits of terminology. So a feature is some kind of input variable that you're going to use for prediction. So it might be the height and width of an image. It might be the different RGB channels of your image data. Or it might be whether a particular document is talking about AI or whether it's talking about Java. Okay. If we're working with labeled data for classification, that's the value that this thing should map to. This image should be a dog. This image should be a wombat. So that's when we know what it is. Training is the process of taking this bucket of data and a list of labels or some sort of scoring parameter and getting out a model. And then inference is when we take that model, we hand it to something it's never seen before, and it says wombat. If all of this is new to you, Google have got a pretty good crash course on a lot of this terminology that you can go look later. A few more things. So regression is for continuous variables. if a house is in this bit of California with this many bedrooms, what do we think the likely price is? Classification is the discrete values, so is this a dog or a cat? And then clustering is where you're saying these things are like each other, these things are like each other. So if you know what those things that it should be grouping into, that's the classification. And if you don't know what it is and you've just got some sort of sense or scoring, then that's the unsupervised machine learning clustering. Okay, so we've got our Word document. We've turned it into some text. We've got that text available. The next thing we have to do is break it down into smaller units, into tokens. Typically what you'll do is just split it on white space or something like that. If this is all new to you, go look up any Lucene talk. It's the same kind of thing for searching and information retrieval. But we've got to get our text into chunks, for example, words. Okay, now we need numbers. So the simplest thing to do is build up a term dictionary. So for every individual word that we find in our input text, assign it a unique index, and then we can take our text and say, the mouse ran up the clock, it's these particular word indexes. So we're getting into nearly numbers. We still want things between -1 and 1, but we've at least gone from text into numbers. The next thing we can do is count how often that particular word or token occurs. If we're just saying present or not present, that's called one-hot encoding. So it's just ones and zeros. Another thing that's common is continuous bag of word count. Just literally how many times have you seen this word in the text? The final trick for simple text in AI is called TF-IDF, term frequency, inverse document frequency. If a word occurs a lot in most of your files, you probably don't care about it. Whether or not a word contains the or a, not going to have a huge impact on the outcome of your AI. If a word occurs a lot in one document but not the others, it's probably really important for that one document. But if your document is really, really, really long, it's going to manage to cram loads of different words in, and that's maybe going to be less relevant than if we've got a single short title that contains the word. So you want to rate rarer terms higher, common words lower, that sort of thing. There are better algorithms out there, and the Lucene folks can tell you about them, but this is one of the simplest ones and one that most of the AI frameworks implement. So based on the continuous bag of words and then the TF-IDF, we can get something into 0, 0, 0.1, 0, 0, 0.5, that kind of thing, which is ready to feed in. Okay, so our next challenge with our AI is we've got our vector of numbers for the different words, but we don't know which is the right talk. We don't know which is the right help document. Ideally, what you do is go off and do a load of analysis with real humans and get them to go and rate your talks or get them to go through the help documents. The trouble is that those people are normally really busy or expensive or something like that. So one thing that you can potentially do is just use text similarity at the start, then ask your users of your real system to explicitly or implicitly rate your answers, use that to build up the training data, and then finally do something really cool 6 months down the line where you've got real answers from real humans who maybe didn't realize that every time they were clicking through and you were measuring how long they were on the page, you figured that if they went to a page and then clicked off a link, then they probably liked it. If they went to a page and stayed there for 2 minutes, maybe they made a cup of tea, or maybe they actually found that one relevant. And if they click onto a page and then click back again quickly, that was probably the wrong answer. So you can maybe, by doing some weblog scraping or analytics, find out which answers matter to people and then later on use that. But for now, we'll cheat and just do some text similarity. So, first bit of AI then is we're going to build a classification model for our talks, train it from the title and the abstract with a TF-IDF, get the nice vector, and then we'll ask a model to classify our query, and we'll say, which talk is this query like? And then find other similar talks. And in the end, to do it with Scikitlearn, the answer is this bit of code here. It's actually pretty good. It fits on one slide, mostly understandable. So you can do this stuff relatively easily. If you want to play with it, then you can have a look on the Azure notebook. The code's there, including all the setup and the loading and so on. But all we need to do then is build the vectorizer, feed in all the data, build some sort of classifier. So this is a multinomial naive Bayes, which is quite a simple one. Chuck the text in, and away we go. And then this is the prediction. So we take a bit of text, we turn it into a vector space again, we ask the classifier which talk is like that, and this is then going to give us back the ID of the talk. We turn that back into a title, and we're away. So, shall we see if the demo gods are smiling on us? People want to see that I haven't just made it up? Let's go over here. So, build a TF IDF, build a model, hopefully. I had run all these in advance, and then Azure kicked me off when I moved from the other room, so sorry. Come on, demo gods like me. No, okay, here's one I prepared earlier. So we did a query here for machine learning, and it came back with some talks that were vaguely relevant to machine learning, but not perfect. So this is the disadvantage of this, is that we don't have any proper training data. So just taking some of the individual words, ignoring their place in text, ignoring the semantic meaning of them, and just treating them as individual tokens and trying to do similar things, we might get an okay response, or we might not. Oh, come on, back in. So, next approach we can take is to cluster the talks. So we want to try and figure out which talks are similar to other talks based on the text contained within them. So the simplest way to do that is with something called k-means. So we're going to say, build an AI model that's going to figure out which things are near which other things, group them together, and then we can say, if you're interested in this one talk, you're going to probably be interested in the other talks similar to it. Likewise, if you're interested in one particular help document or RFP response, then other ones that are very similar might be of interest to you too. Now, the challenge with clustering is, how many clusters should you make? So if we've got k terms in our TF-IDF, let's say we've got 1,000 different words in all of our talks. If we have 1,000 clusters, then each talk is going to fit perfectly into each cluster, 0 error. But it's not a lot of help if every talk is on its own, because then it's got nothing else with it, and we can't figure out what's similar. Likewise, if we put everything into one group, then everything has the maximum number of neighbors, and our error is absolutely maximum, and all we can say is, people who went to this conference liked other talks from this conference. People interested in help also wanted help. So we need something somewhere between those two. The other challenge that we're going to face is if we're randomly initializing our clusters each time, and we run and build a model from a random seed each time, we're going to get different answers at the same size. So random could potentially help us find the best thing, but we're going to need to run it a few times, and potentially if we find one seed that works well, save that and use that again. So if we calculate the score based on the amount of error, and we increase the size of the clusters, we see that the bigger the cluster size, the more accurate it is, the more we get to every talk being on its own. But it's it's not uniform. There's certain sizes that work better, certain sizes that work worse. So this is the next kind of lesson for your AI, is that you're going to have to go and measure how different parameters affect your data and then make decisions for yourself. So you might look at this and say, well, I've got about 1,000 talks, something around 50 is about right. Let me find the value that's the best match around that point and go for that. Or you might look at that and say, oh, actually, I think maybe we want something about 70. So depending on your needs, depending on how long you can wait for this to run, the bigger the number of clusters, the longer it's going to take to get the answer, you can make a decision that's right for you and for your business on how we should do the clustering or how we should tune a hyperparameter. There are not simple answers. It's not just like saying, oh, my unit test has gone green, we're good. You have to start thinking about what's going on, what this data means, what the outputs of this mean, and then make best guess judgments on the parameters, on the error measures that you get. Unfortunately, this is a sort of slightly hand-wavy world that you're moving into now. Okay, so that was the graph just for the cluster size to error. But when we've got all the text, so I've just got the text from 5 years of Berlin Buzzword talks, and I ended up with about 20,000 entries in my TF-IDF. How many dimensions can we think about? Maybe if you're a specialist astrophysicist, you can get up to 6 or 7. Most of us top out at 3 or 4 dimensions. So we've got a problem that we want to visualize how our model is doing, and it has all these thousands of dimensions, even hundreds of dimensions, which is more than we can cope with. So one of the things that we can do is we can use a technique like TSNE or PCA to throw away a lot of those dimensions and then give us something that our brain can cope with, so that we can then look at it and say, that one's probably better than that one. Now, we are throwing away information, so it's not going to be perfect, but it's probably the best thing we can do to have a sort of finger in the air check of, is our model working? So you end up with things that look like this, or things that look like this. So the TSNE one, we're including color as well, so that we've got 3 dimensions. So we've got the X, the Y, and the color. It's a bit washed out on this. Have a look at the slides later. It's still not perfect because we're still trying to map all these different dimensions down, but you can look at that and say, well, on the whole, things are fairly spread out. There's not too much really close to other things. Probably the grouping's looking okay. But it's not, you're not just going to get a big tick or a cross. You're going to get fuzzy information that you've got to make sense of. I'll skip over a bit more on clustering, and I won't do the demo because Azure doesn't like me in this room for some reason. Okay, so the next thing we might want to do with our talk data, or you might want to do with RFP responses or something like that, is start adding a time dimension to the scoring. So for example, we might say, we're going to recommend videos of past conference talks to you that might help you find the answer to your question. So could we prefer newer talks to older ones? We're in the tech industry, things move relatively fast. Maybe a newer talk is better than an older talk. So we can't necessarily easily add it as a feature, because at query time, you're probably not going to say, give me talks from 2018. You're going to say, help, my boss has just told me I've got to introduce Kafka by yesterday. We can add it in at scoring time, but we need to take care that we don't push things into, for example, into a different cluster or mess up the similarity on the vector space. If we take the TF-IDF weights and we say, oh, well, we're going to shrink the TF-IDF weights for everything that's a really old talk, we can end up moving it. So instead of being over here with all of its friends, it's been shrunk down near the axis, and it's now surrounded by other talks that are not relevant. So adding these kind of things in is trickier. And then our data isn't long-term static. So next year there's going to be another Berlin Buzzwords sometime in July. That means there's going to be another 100-odd talks to go into our data set. You've built your model of RFP responses. Another query comes in from a new customer. You need to add that extra question into the data. You've got the training data for your system at work. People are adding new features to it. So you can't just trust the human-provided answers that you've got, because if someone adds something new in that's novel, there's no ratings for it. There's no classification for it. But if it's new, then maybe it's going to be more important. So you're going to have to deal with that challenge yourself. Say, well, how much do I value novelty? How much weight do I give to new things? How do I boost things that have no other ratings? How much should I de-weight the old things? That answer, you're going to have to try a few things out, look at the answers, maybe sit down with someone from the business and say, which one of these three would you have really wanted? And then we'll tweak the parameters and see which one comes out. Skip over that. Embeddings and feature extraction. So with our text, if we took all the text of all the Berlin Buzzword talks and put it through a TF-IDF, we got 30,000 different tokens out. Most of those are 0. If we're using something like Bayesian or k-means, it's okay to have lots of zeros. Takes up more memory, but as we saw, 4 terabytes, $25 an hour, we can just kind of be lazy. But if we are trying to work with some of the neural network techniques, then we really want something where most of the different dimensions have a value in. So we're aiming for something with maybe 50 or 100 features that have value, not 30,000, most of which are 0. Otherwise, it won't fit on the memory of your GPU. And if it won't fit on the GPU and it has to go into main memory, it's just got 100 times slower. So if we want to do neural networks, if we want to do GPU accelerated, we've got to think about shrinking our data down so that it will fit onto the core of the GPU or something like that, so that it can be fast. And so with text, that means that instead of just doing a TF-IDF, we've got to come up with an alternate way of getting the text into features, and that's around the embeddings. Another problem with TF-IDF is that you've got no semantic information. Word order matters. My Kindle is easy to use. I do not need help. Great. I do need help. My Kindle is not easy to use. Bad. Now, those two things will have exactly the same TF-IDF representation, because we're throwing away the word order. All we're caring about is which words happened in the document somewhere. So we're going to need to give someone very different answers, very different help, depending on which of those two it is. But if we're just using TF-IDF, we've lost that. So there are a bunch of different embeddings and approaches. For those of you who want to go off and do reading later, these are some of the main ones to go and read up on. I'm not sure why there's Elmo and Bert, and I think someone was having fun who's a fan of Sesame Street. They don't all have silly names, but a lot of them seem to. I think a lot of geeks seem to like funny names for things. Probably the easiest one to understand, and one of the ones with the best talks out there, because it's been around the longest, is Word2Vec. So it's originally developed by Google, and it's trying to put things with other words with a similar meaning, and also so that as you move through the vector space, you get a similar semantic meaning as you move through it. So that hopefully you can say, man is the boy, what woman is the girl. So we've taken these concepts, and then when we move through the vector space, we'll end up with a word with the same relative meaning to them in a graphical form like this. And that way, when we're trying to produce an AI based on that, if you give it a word that it has seen before, but in a different context, it can then try and make an inference and make a prediction that will be similar. Okay, next thing to be aware of, testing cross-validation. So if I have 100 pieces of data and I feed all of them in the training step, I've got nothing left to test how well it worked. So if I fed a model 100 pieces of information and then I feed it the same 100 again, it's probably going to do pretty well. I mean, if it doesn't, then there's something wrong with your AI. But on the whole, if you give it a piece of data to train on and then you ask it to predict, it already knows what the right answer is, so it can cheat and give you the answer back. So when you're doing your training, you need to keep some of that data back so that you can check how well the model works on all your data, because it can do too well and it can end up overfitting. So generally, you're going to want to have a split. Some of your data for doing the training, some of your stuff for doing the testing. If you don't have a lot of data, which is often going to be the case with this tech stuff, where you maybe got 2 hours of an expert's time and they classified 50 documents, you might need to try slicing the data up multiple different ways, training the model on multiple different slices, and then make sure that you get roughly the right answer out, and that will tell you that your model is not overfitting or underfitting. Hyperparameters, really sort of sci-fi sounding thing. It's basically any knob that you twiddle on your AI that's not part of the input data. So that might just mean, what is the size of my cluster? What's the initial seed that we're going to use? If you pick the wrong parameter, then your AI might spend a huge amount of CPU cycles or GPU cycles trying to get out of a local minima to find the best solution. Or it might even just give up early and then you haven't got the right model. Being good at picking hyperparameters is why some data scientists are able to attract huge amounts of salary. Is though finger in the air. They are looking at some of these graphs. They are trying to figure out what's going to be the right kind of place to start the AI off when it goes off and learns its models. Okay, errors. Errors are important. Different kinds of errors. So we can have true positive, false positive, true negative, false negative. Does everyone know what those mean and so on? Depending on what you're doing, the thing that you want to optimize for is different. If you're trying to detect cancer, is it better to say to someone, it's okay, you haven't got cancer, you're free to go, when it turns out they have and now they go off and die? Or is it better to go to someone and be like, I think we're going to have to take your arm off. Turns out it was fine later, but it's better to be safe than sorry. Hopefully your data's not going to be quite as critical as that, but again, you're going to need to sit down with the business and figure out what is the right answer. How do we need to tune the AI so that we get the best answers that we can with minimizing the errors that matter to us. Another thing you need to be aware of is biases. So if your input data is biased, your model is going to be biased, which means that your predictions are going to be biased. You can try and hide biases from your model, but if you do it badly, they'll still come through. So you might say, okay, I'm going to train a model on people, and I'm not going to tell it the gender. I want it to be gender blind. But I'm going to leave in everyone's name. And unfortunately, your AI might then learn which names tend to be female, which names tend to be male, and then it's still figured out if you're male or female, and then it's got the original bias in. You might say, oh, well, I'm worried about racial discrimination, so I'm not going to teach my AI about race. But if I've just left in your postcode, your zip code, or which school you went to when you were age 5, and you're in a country where people tend to live with other people from their race group because of historic discrimination, then you've still kind of taught it about the race. And you might say, oh, it's okay, my AI's gender blind or race blind. But if you didn't properly debias your input data, you're just kidding yourself. Okay, Apache MXNet. Had some hands up earlier for people using it. Any developers of MXNet in the room before I put my foot in it? Okay, it's a really good project. It's still in the incubator. I think it's going to be coming out fairly soon based on the board reports. Works for a whole bunch of different languages. It's got all sorts of pre-trained models available, and you can run it on your CPU or your GPU. You can use the same code, so it's great. If you want to play with Apache MXNet and text, there's a few different things to look at. There's the text contrib package, which has a lot of things for working with the word embedding models. So they have things for Glove, for BERT, those kind of things. And they also have pre-trained models, so that you don't have to go and teach your model about English or something like that, you can say, someone else has already spent some time and a load of CPU credits teaching it about the English language from Wikipedia. Just give me the resultant model. And it has the code in there to download that and cache that and work with it. If you're interested in diving into more, I'd suggest the d2l.ai domain. I think it's deep dive into AI learning is what it's called. So that's an online course about AI, machine learning, deep learning, using Apache MXNet as the reference library that's available. It's being taught at a couple of universities. I found it really helpful. Okay. If we want to use Apache MXNet to figure out which words are like which other words based on the Glove word embedding and a bunch of Wikipedia text, this is all we need to do. This code will run on a GPU if you have one and you've got the right bindings available. The very first time you run it, it's going to take between a minute and an hour, depending on your internet connection, because it downloads about 800 megabytes of precompiled data. I ran it earlier on my laptop. It was pretty good. I ran it on Azure. It was slightly less good, and then it kicked me off. Just set expectations. But you can connect, download the data, and run it. So in this case, if you run it and ask it for things about Linux, it will tell you kernel, GNU, and Unix. And it will say these are similar words based on what is in Wikipedia to Linux. So rather than having just that simple TF-IDF, we can have the complex vector space model from this for free, just with a few lines of code and a few 100 megabytes of temporary disk space on your machine. It's a bit less readable than the Scikit-Learn code. It's a lot more readable than the version of this I saw for Google's TensorFlow. So it's sort of somewhere in between in terms of understandability and readability. If this code is looking like gibberish, then have a look in the D2L AI course. These code samples are inspired by the stuff in that, and they go into a lot more detail about what's actually going on for this kind of code. But if you clone the workbook I've got on Azure Notebooks, or if you grab the code from my Apache homepage and run it locally, you can run through this. You can try different words, have a play, see how you get on. So we built our model. We've run some predictions. It's told us what words are like what other words. We can then go off and train an AI based on that. Then we need to put it into production. So you're making some changes. Has my model improved? Is it better than the old one? You're going to need to have some sort of heuristics in there so that you can check when you tweaked a hyperparameter, have you improved it? Have you made it worse? You're also ideally going to want to store checkpoints over time so that you can compare how were we doing 6 months ago to now and what changed and compare the differences. If you're not sure how to do that, the best example I know of is Apache Tico eval. Apache Tico, I already mentioned at the start, text and metadata extraction library for pretty much any file format out there. With Apache Tico, there's a regression library of about 4 terabytes stored on a machine at Rackspace. Thank you, Rackspace, for the free hosting. And every release as a project, we have to figure out, have the changes we've made improved or worsened our overall performance? No amount of Amazon Turk credits is going to let us get that kind of answer by giving every single document and every single piece of output to real humans and getting an answer. It's just not possible. So we have to have some sort of finger in the air heuristics. So we look at things like, how many exceptions did we get? How many timeouts did we get? How many out of memory problems did we get? Now, some of those are just the machine falling over. I mean, it's a free machine, we can't complain. But some of them are because we've made a change to a library or upgraded a library and it's affected it. We also need to look at things like, how long did it take? If extracting from a PDF used to take an average of 500 milliseconds and now it's up to 500 seconds, probably we've stuffed something up. You can look at the common engrams. If extracting from PDF typically produce words like the, a, that kind of thing in English, and now we're getting z, 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 probably something's gone wrong there, and it's gone wrong on the PDF. If you look at it by language, split by language, you can end up having a more useful set of information. So even if you've only got 50 German documents in your corpus, if you compare the German documents separate from the English documents, you'll get a different top answer, and you can look at it and go, are those actually German words? You might look at it and go, well, what we thought was going to be German words all seem to be French. Maybe we've stuffed up the language identification. But these are all just something where someone is going to look at a dashboard once per release and say, how have we done? And it's going to be a similar thing for you with your AI models. You'll build a new model, you'll feed in some test queries, you might split it different ways, look at it and go, should we put it live? As I've said before, make sure you know how to recreate your model. There used to be a thing a while ago, maybe 10, 15 years ago. It worked on my computer. Bit before that, it compiled on my computer. With some of the data science, data engineering at the moment, it can be like, well, it gives the right answer on my laptop, or at least it did last Tuesday. If this is something that's going to be important to your business, and sometimes the data scientist laptop works and sometimes it doesn't, and it never works in production, that's going to be a problem for the people paying the bills. So do make sure that you have all of your training data stored somewhere, ideally versioned. Make sure you have a record of how you're pre-processing your data. So in my case, I might say, oh, I'm training it on a Glove word embedding, and I'm using this specific Glove word embedding with these many words from this date, so that I know how to recreate it. If possible, when you're storing the model, so you built your model and you're going to put it somewhere to serve, try and put that information with it, just that metadata, so that when you're looking at a model in production and everyone's going, why is it that we keep asking for talks on AI and ML and it keeps suggesting stuff on Lucene? You can be like, well, these are the parameters that we put in, let's go off and do some testing, let's see what's going on. And if you've stored the parameters with your resultant model, you've got a way to work backwards. If you just say, well, there's 500 megabytes of stuff on the server with this SHA. We think that's what we deployed last week. You've got really no hope of being able to support this. And yeah, you're building this for a reason. Someone's paying your salary, someone's paying your server costs. They probably want some useful answers. And if you can think about this up front, then when it goes wrong in production, you've got a hope of fixing it rather than someone saying, what the hell are we paying you for? Some Apache projects to know about. Apache MXNet, obviously. If you're interested in the NLP, then have a look at their gluon NLP subproject. It's got a lot of stuff already available for you, a lot of the embeddings, a lot of the techniques that you'll need. Apache Tico to get your Word documents or whatever into some useful text. There's also a bunch of other projects in the incubator to be aware of. So there's Apache DLab, which is trying to create self-service data science environments in the cloud. There is Marvin AI, which is a platform trying to help the data scientists, again, experiment and prototype in the cloud. Apache Singer, who are trying to do really scale-out versions of all of this. And then Apache TVM, which is also trying to help you compile your code down into something that will run on a CPU or a GPU. So there's some of the new projects at Apache from the last year or so that you might not have heard of yet that may be worth checking out. Another thing, if you've actually got questions and answers in your text, rather than trying to retrofit questions and answers onto the text that you found on your server or from your users or whatever, then Facebook have developed something called Dr. QA. There was a talk on it at Berlin Buzzwords this year that's worth checking out if you happen to have meaningful questions and answers in your text rather than just a load of text to make sense of. There were 2 relevant talks at ApacheCon North America in Vegas from 2 months ago. There was the recent advances in natural language processing from the Apache MXNet folks. Sadly, the audio recording of that doesn't seem to work, so there's no audio recording, but there are the slides available on the website. The other one is the Evaluating Content and Text Extraction at Scale talk by Tim Allison. You can get the slides and the audio for that online. So that's all about how Apache Tico tries to finger in the air, figure out if things have got better or worse. And you can use a lot of those same techniques for understanding if your AIML pipeline has got better or worse. If you want to try it out yourself, you can have a play with Jupiter notebooks. There's also Apache Zeppelin notebooks. Both Microsoft and Google will give you free hosted Jupyter notebooks to play around with, so you don't have to worry about installing anything. You don't have to worry about any dependencies. You can just point your browser at it, start coding, hit run. With both of them, try and have a stable internet connection. If you're hopping from IP to IP and putting your laptop to sleep, then with the free ones, they have a tendency to shut down the container that you're running on, and then when you wake it up again on stage, your demo doesn't work. If you're paying for this stuff, if you've got your own hosted version of Zeppelin or your own hosted version of Jupyter, you can tune the security settings and keep those persistent while you move around your company or go for a cup of coffee or something. On the free stuff, it is a bit more flaky, but you haven't paid for it. You haven't installed it, so trade-off there. If all of this is new to you, there's a bunch of really good learning courses online. I won't dwell on them, but you hopefully all got the slides at the start, so you can go look those up later. There's a couple of books available as well. We have 0 minutes left, so I'm going to leave you with the slides and the code again. I'm going to be around, so any questions, just come up and talk to me afterwards. I will happily answer your questions or point you to other people, but I am now out of time, and I know a lot of you will need to get some fresh air or something, so I will stop there. Thank you for your time.
Thank you, Nick.